So remember the unit circle. Why do we call it the unit circle? Because all the segments that come from the center, the origin, to a point on the circle are 1 unit long. And what are the points on the unit circle? Well, they have an x coordinate of this if we were to make a right triangle, and a y coordinate of this if we were to make a right triangle. Right? And then remember, if we made one here, it would be negative x comma y, and then 1, if we made one here, it would be negative x negative y, and 1, if we made one here, it would be x negative y, 1, etc. Well, you guys know how, and the reason we use right triangles is so we can do the trig. So remember, this is always the angle. The angle that we are referring to is always coming out from the origin. It's between the origin and here and the horizontal. That's theta. So if we draw it over here, it's going to be theta here. Theta is always coming out from there. Well, you guys know how to find the cos of any angle in a right triangle. It's always the adjacent side over the hypotenuse, right? Well, in this triangle, what's the adjacent side? It's x. What's the hypotenuse?
1.
And x over 1 is just x. So the cosine of any angle is always the x coordinate of its point on the unit circle. So if you think about it, the cos of 45 degrees would be the x value of its point on the unit circle. At 45 degrees, what is this value? Right. And if you were to do cos 45 on your calculator and get the decimal, and if you were to do square root of 2 over 2 on your calculator, it'd be the exact same answer. Okay? For sine, well, sine is opposite over hypotenuse. But in this triangle, it's going to be the opposite side is called y, or the y coordinate of the unit circle, over the hypotenuse 1, which is y. So to calculate cos and sine of angles using the unit circle, we just have to look at their x and y coordinates of the corresponding points on the unit circle. For tan, so that's really just reading. For tan, we do have to do a little bit of calculating because tan would be opposite over adjacent, which according to our right triangle up there, that's fitting to the unit circle, y over x. So what am I trying to say? The coordinates of any point that is on the unit circle, its x coordinate will be the same as the cosine of the corresponding angle. The y coordinate will be the same as the sine of its corresponding angle. And then tan, we have to do some work, y divide x. So how do we do these things? Here's what I would suggest. And you guys will probably get to the point where you can visualize it in your head. To find the sine of 150. Sine means y coordinate, right? I'm going to read the y coordinate. What am I going to read the y coordinate of? That point at 150 degrees on the unit circle. So what point is this? This is negative root 3 over 2, comma 1/2. So what's the y coordinate? 1/2. So your answer, that's it. So if you were to do sine 150 on your calculator, it'd come out 0.5. So you figure out whether it's the x or the y value that you're reading, and then you get the point on the unit circle and read its x or y. So the sine of 45. Sine means I'm looking at y coordinate of this point on the unit circle at 45 degrees. What is this one at 45 degrees? Root 2 over 2. The cosine, to calculate this, I need to read the x coordinate of the point on the unit circle that corresponds to 150 degrees. Well, we did 150 degrees in the first one when we found sine. What would this one be, the x coordinate? Negative root 3 over 2. The tan, we've got to do some calculation. We've got to find the y value and divide by the x value. So at 240 degrees, where is 240 degrees on the unit circle? It's there. It's not in the middle, it's low. What's this point on the unit circle? Short, long. Negative 1/2, comma, negative root 3 over 2. So that means we have to do some calculating. We have to divide negative root 3 over 2 by negative 1/2. Well, how do you divide fractions? Change it to multiplication. Negative root 3 over 2 times 2 over 1. I've got a times 2 up top and a divide 2, which cancel each other out to 1. So I am left with negative root 3 over 1, sorry, positive root 3 over 1, which simplifies to root 3. So cos, read the x, sine, read the y, tan, divide the y by the x. Try the next two on your own. Try the next two on your own. Anybody want to share sine 330?
Negative 1 over 2.
Negative 1 over 2 is right. Right? And again, you don't have to do this, but we can just say, oh, that's y. 330 is the one that's down here, but close to the x-axis. So it's the y coordinate, which is the short one, but it's going down, so it's negative. Negative 1. 225?
Negative root 2 over 2.
Negative root 2 over 2, because cos means x. That's the one that's halfway into quadrant 3, where the values are the same. And they both happen to be negatives. So the sine of 225 will be the same as cos of 225. Tan of 90. Well, tan, remember, is y divided x. 90 degrees is up here, right? What's the point on the unit circle up here?
0.
0, 1. So in order to find it, I have to do 1 divided by 0. What is 1 divided by 0? Can't do it, so it's, what's the word we use? Undefined. And you'll find that again If you do that on your calculator, tan of 90, it'll give you an error. And it's telling you can't do it. Cos of 60.
Negative, no, sorry, it's root 3 over 2.
Sure. So isn't the x coordinate the smaller one? What's smaller of 1/2 and root 3 over 2?
1/2.
And 135, I'm going to have to do y divided by x. 135 is the one that goes into the middle. In quadrant 2. That's negative. Remember, that's negative root 2 over 2 comma root 2 over 2. So I have to do the second one, root 2 over 2. Divide the first one, negative root 2 over 2. Well, I don't need to change this to multiplication because what's anything divide itself? 1. But anything divide its negative self is negative. I mean, you can switch it to multiplication. It's still going to work out to negative 1. And finally, the sine of 180. Sine means y. 180, I'm over here. What's the y coordinate? 0. So the sine of 180 is 0. That's how we use the unit circle to find exact trig values. The next step and the last step that we're going to talk about trig this year is going backwards. What if I tell you this? You could probably figure it out. But this is going from a trig expression to a trig equation. What angle would fit that? No, angle. What angle has an x coordinate of root 3 over 2? 60? There's no 75. 30 has root 3 over 2. But there's another answer where it's root 3 over 2. Down here too. Okay, this is just sort of a preview of the next lesson, but that's sort of what we're going to be doing. Okay, is working backwards. And you can see now that when we solve trig equations, there's going to be more than one answer.